I'll be speaking today about some of the experiences we've had implementing IPv6 over the past few years across our network. First of all, I'm going to start off talking about the upcoming IPv6 transition. Given Owen's talk, I'm going to be fairly brief on that since many of you have gotten some of the background done already. I'll then be talking about IPv6 and DNS because, in a little more detail, because it's an area where there's a lot of confusion that shows up commonly, and it ends up being important for how you, as at least a site provider, might control the transition. I'll be speaking some about the role Akamai is hoping to play in the IPv6 transition and where we are now. I'll be talking some about World IPv6 Day back in June and also some next events coming up. And I'll also be talking about some experiences we've had, both lessons we've learned as we've been implementing it, as well as common confusions we've identified both when talking with customers and talking with internal folks. So background motivation here is the internet's running out of IPv4 addresses. With only 4 billion addresses around, that's not even enough to give one address to each of the 7 billion people on Earth, let alone all the embedded devices that they may have. And in addition, if IANA ran out and APNIC also has exhausted its address space. And if we look at some data from Jeff Houston, it looks like RIPE is likely to run out sometime in the 2012 timeframe, and the current projections is that Aaron's going to be running out in 2013-ish. And both those may enter into some sort of austerity mode before then. And as a result, the impact of the shortage of IPv4 space is going to start showing up, whether it's more NAT, secondary markets for IP addresses starting to appear and making them more expensive, or other side effects. So what are the alternatives to this? One of the ugly ones that we may start seeing more of is more people using NAT, which is network address translation, in particular in a mode called NAT 4-to-4, which is translating between IPv4 addresses and IPv4 addresses. And this means that ISPs may stop giving out global addresses to the users, which means as a content provider, someone might start seeing instead larger numbers of users starting to come from single addresses. So it may not be just like big corporations and mobile networks, but also start seeing some sorts of large ISPs where you have multi-layered NAT, so you're seeing all of the users from one location. And there's also challenges with NAT where there's no direct connection between the little private bubbles of address space without stun. Also, NAT's not a viable option for servers. So going into the IPv6 world, one thing that I find kind of tough in the organization or tough when talking to people is to kind of help wrap their heads around is how does IPv6 relate to IPv4? And one way to think of them is that IPv4 and IPv6 are two different internets that don't have direct compatibility between each other, although there are hosts which are referred to as dual stack machines that are connected to both internets. And many routers can be and are dual stacked such that they're on both the IPv4 internets and the IPv6 internet. But if you have paths from one point to another, you shouldn't necessarily expect there to be any correlation between which routers they go to between IPv4 and IPv6. Also, at least in the current IPv6 world where there's not much content available, an IPv4 only user is in a very, very lonely place right now. So at least many of the deployments that are IPv6 only, such as within some mobile networks, use technologies such as NAT 6-to-4 combined with DNS 6-to-4, which provide them at least some access to the IPv4 internet, although there are some interesting side effects of this that we'll talk about later. As a company that tries to get content out, help our customers get content out to our customers' end users, one of our biggest focuses has been on IPv6 user adoption. So I'll be focusing on that in this talk, but it may be that within your organization you have a very different focus. Your IPv6 priorities may be different. But in terms of getting content out to IPv6 end users, the initial blockers at a very high level, we're getting some support in the operating systems, getting client software support in place, getting the infrastructure, the backbone of the internet to support IPv6, as well as having some content to be available and end users to have connectivity, and to make things even more challenging at the end, getting customer premise equipment devices such as home routers to support IPv6. So where we are now, we're in a pretty good state where most modern operating systems, most modern web clients, and at least some infrastructure and the internet backbone have IPv6 support, although there are still plenty of issues remaining in that area. Some of the big areas that are remaining, however, is content availability. There aren't that many websites, although there are a few that, large ones that have some IPv6 content available, but also end-user connectivity. There aren't that many IPv6 end users out there. And to make it even harder to get IPv6 end users out there, very few of the home gateway devices properly support IPv6 in a meaningful manner. So there's now a chicken and egg problem that's appeared here, where many content providers over the years had been hesitant to do a lot of work to make their content available over IPv6 because there was no one to go fetch that content, and ISPs were hesitant to start invest in having large numbers of IPv6 end users because there wasn't any content for those users to get, so it would just be degrading the performance. However, there is some hope for that, which I'll be talking about shortly. When looking at metrics of client adoption, one thing that's important to differentiate is between clients that are IPv6 capable and clients that actually prefer IPv6 and will use it. So a client is capable if it has some ability to reach an IPv6 only host or content. And for example, however, a client prefers IPv6 if, when given the choice of a dual stack site, which has both IPv4 and IPv6, they'll go and make a connection to that server over IPv6 rather than IPv4. And some of these tunneling techniques, such as 6-to-4 and Teredo, have a side effect that in many recent operating systems and clients, they've been depreferenced to the point where if there's a dual stacked site, they will only go to it over IPv4. And right now, looking at the user base out there, only about 2% of the IPv6 capable clients with 6-to-4 Teredo will actually prefer IPv6 when going and fetching content. And even clients that are using native IPv6 will sometimes fall back to IPv4. So what does the IPv6 internet look today from a content and user perspective? There's some content available, but not a huge amount. And there are some large sites that have made some IPv6 content available on a significant scale. And there's some small percentage of client adoption. For example, kind of over this year, globally, there's been around 0.3% of the users that prefer IPv6 over IPv4. Looking at some data from Google, you can see that over the year, the amount of native IPv6 preference has actually been increasing among clients. And along with that, the amount of 6-to-4 and Teredo traffic has actually been decreasing substantially to almost nothing. Another thing in the IPv6 internet today is that the IPv6 peering between networks is much more broken than it is on the IPv4 world. There are a lot of networks that may have set up some peering or may have started giving IPv6 out to end users or customers of theirs, but may not have actually set up peering properly to the same degree that they have with v6. You find some networks where there's just no way to get from point A to point B over IPv6. In addition, there are many broken or partial implementations out there where some developer was handed a spec saying, go implement IPv6. And the developer didn't really understand the RFCs and implemented something, and that thing doesn't really work all that well. If we look at end-user adoption by country of IPv6, it varies widely across the world. For example, there are some countries where there's almost no IPv6. Whereas some places like France, due to one of their ISPs called Free that is using a protocol called 6RD for their users, there's actually in Norway, which just seems to have a lot of technical people interested in IPv6, there's actually a significant portion of the user base that's adopted IPv6, whereas the US and Canada are somewhere in the middle, somewhere near that global average of 0.3%. And this data is from some beacons that Akamai has running that collects data on kind of on what the end user IPv6 situation looks like. And Japan here is actually a particular challenge because there are some networks within Japan, like KDDI, that have made a lot of IPv6 available to the users, but due to some regulatory constraints, there's actually a situation that's developed among a lot of the home broadband users where the way in which they can get IPv6 addresses in a way that is oftentimes broken. So if you start handing out Quad A records for those IPv6 users in those ISPs, you'll actually hurt the performance for them, even if they're not going to be using IPv6. So going forwards and looking kind of into the future, because this is important organizationally for planning, no one has any crystal ball here on what this traffic is going to look like. Lots of people have guesses. This is a totally random hypothetical guess, kind of based upon where, kind of seeing where things have been going recently. In particular, it looks like there's an inflection of content coming soon. At least a number of the big content providers are very committed to making IPv6 content available. And in addition, there is hope on the end user side as well. There are a number of large end user internet providers that are starting to provide IPv6 in the US, Japan, and elsewhere. And as a result, we expect to see both the amount of dual stack content ramping up and the number of clients preferring IPv6 ramping up. But it's also important to understand that the traffic is actually a function of the two of these. So the IPv6 traffic growth, at least for content from websites, not including necessarily peer-to-peer traffic, is going to grow slower than either of those. And the result of this is that if you kind of look out a few years, what it's likely to look like is an internet that has a significant portion of IPv6 and a significant portion of IPv4, with some attempts for people to try and communicate between those, and it's going to be an interesting morass, which means, and the end game of this, of when are we going to ever get to getting rid of IPv4, at least before we have to go through the 2038 fun of dealing with 64-bit timestamps, is a unknown at this point. In fact, I kind of wonder if that push to have to deal with 64-bit timestamps is going to force enough people to upgrade old stuff to finally be the death knell to IPv4. So what control, if you're providing content on a website, for example, what controls whether end users are going to come and fetch content over IPv6? And that's DNS. And DNS controls that content availability, but only hand in hand with the client behavior. Because how a client is going to behave if you handed a Quad A record and an A record will vary greatly based upon the client software version, the OS, and the browser. And I'll talk a little more about that later. And in IPv4 world, the DNS names that return IPv4 addresses are A records. And in the IPv6 world, the address that returns, or the record that returns an IPv6 address is a AAA record, which is very hard to say, so people just refer to this as a Quad A record. And you can have both of them for the same host name. So you can have www.example.com having both multiple A and one or more Quad A records in its own file. And it's also, but one thing that's important to kind of realize is that you can't have a Quad A record return an IPv4 address. This is something that sometimes when you're talking to some developer, it takes you half an hour through a conversation, and then you finally realize that, oh, that's what they've been confused about. So you can have both A and Quad A records at the end of a CNAME chain. For example, you can have a website CNAMing over to some other name, which then hands out an A and a Quad A record. But you cannot split off the A and the Quad A record in a CNAME chain. You can't have a Quad A record for www.example.com, but also have it have a CNAME over to something that returns an A record. And we've seen this cause a lot of confusion at the very end of processes where some networking team within an organization is going and standing up some demo version of their website through setting up like a IPv6 to IPv4 HTTP proxy, and they go to their web team and they say, oh, there's going to be so little traffic from IPv6 end users, all you need to do is add this quad A record into the zone and you're all set. But then it turns out that the site is actually CNAMEd over to something else, and that just doesn't work. And it's the same reason, technically within the DNS protocol, that you can't have a NS record and a CNAME for the same name. Is that a CNAME basically says, for everything for this name, go look at this other name. So how do dual-stacked clients behave in this situation? So dual-stack clients may look up both the A and the quad A records. Sometimes they may do it in parallel. Sometimes they may do it in series. This varies from operating system to operating system, and also between versions of operating systems. And the client will often prefer the IPv6 to make a connection if quad A records are returned, although the heuristics for this vary widely, as I mentioned before. On the other side, there's a number of clients that deal poorly if their IPv6 connectivity is broken and a quad A is returned. And that may range from having some delay, which could be in the milliseconds range, which isn't a problem, to not being able to fetch things at all. So in these clients that can be broken by dual stack sites, there's a wide range of different things that can cause this. It can be unreliable 6 to 4. You can have a browser that tries using IPv6 when it doesn't work in IPv4 would be better, such as some of these 6 to 4 situations where the auto-configured tunnel goes into an anycast no man's land. It could be that you have some slow fallback to IPv4. There's a number of browser bugs in a number of major browsers out there. There's ICMP PMTU discovery issues if you're trying to use a tunnel and ICMP PMTU messages are getting dropped. By the way, if you ever set up, since there is no kind of native fragmentation in the middle of the network for IPv6, it's critical that you let ICMP PMTU messages for path MTU discovery through, or have your network folks do that, because otherwise IPv6 just won't work properly in the face of tunnels. We've even seen some home router and home networking gear like home routers that mangle quad A responses in highly creative ways. Because of this, just putting out a quad A record can cause problems. And that for a long time was one of the reasons why many big content provider sites weren't going live in IPv6, is they were wary of the risk-reward trade-off of while there were so few people with IPv6, they were likely to break more people than they would help. In fact, there are actually a few countries in the world, such as Turkey and South Africa, where we looked at our data where the IPv6 situation is sufficiently broken that you'd break a lot more end users than you'd help by handing out quad A records. But World IPv6 Day, that was one of its intents, was to test this out and see what happens if a lot of sites start handing out quad A records. And the realizations is the internet didn't break, things didn't fall over, help desk didn't get lots of calls. And the other thing that's that may help here is that there's a number of recent client changes in recent browsers and OSs that'll help here around a set of technologies called happy eyeballs. And I'll talk about happy eyeballs very shortly. So happy eyeballs is a proposed internet draft to work around some of this broken IPv6. And the idea is that a client should try IPv6, but fall back to IPv4 if IPv6 isn't quickly available, and to remember some state to provide some hysteresis. On the other hand, the actual implementations of this, as people have implemented it, have varied widely. I don't think anyone's actually implemented the internet draft exactly as proposed, but instead have taken slight variations of it in different, interesting, creative ways, and have resulted in a wide, interesting set of behaviors, sometimes with quotes around the interesting. And there's a interesting article by Emil Eben called Hampering Eyeballs that was recently published. And Geoff Houston also had a follow-on article to that talks in more detail about what the actual client implementations do here. And so another thing to realize about IPv6 and DNS is that the question you're asking, like the quad A or A question, is independent of the protocol that you're asking that question over. So so you can ask about for an IPv6 address over IPv4 and vice versa. In fact, that's the normal case. So you could have a client that is IPv4 only go and talk to its DNS resolver over IPv4, and that DNS resolver goes and talks to its DNS authority over IPv6, and then it gets a record back and it goes and talks to its web server over IPv4. You could have another case where a client that's dual stacked goes and asks its IPv4 or IPv6 DNS resolver for an A and quad A record, and that asks its DNS authority over IPv4, and then when the client gets a quad A response back, it goes forward to its web server over IPv6. And if you kind of look through the combinatoric combinations of this, there's a lot of different possibilities here, and this can get confusing for people, especially people trying to implement things in this area very quickly. So next up, I'm going to talk some about what Akamai has been doing around IPv6. For background, Akamai provides site acceleration, content delivery, and cloud platform services for enterprise customers, as well as a lot of big websites. And you're likely using our network every day through many of the sites you visit, making them more reliable and faster. And you likely don't even notice that that's going on. And we have around 100,000 or over 100,000 servers at this point in 1,900 networks around the world in 75 countries. And we've allowed some very large internet events to scale, resulting in almost 9 terabits per second traffic peaks. Normally, and kind of part of what we're trying to achieve here is that normally if you have a client and a web server that are fairly far apart, which could all, oftentimes the path through the internet sometimes might be fine, sometimes it might be not as straight as you might expect because BGP providers, when setting up peering, are maybe optimizing for their cost or policy issues rather than just for performance. And this can result in latency, packet loss, and other issues. So what Akamai does is we put an edge overlay network on top of the internet where requests from an end user can go to an Akamai server that's very close to them, get transferred over the Akamai network, and go to an Akamai server that's close to the origin, get content from there, and then out at the edge near the end user either cache the content, deliver a dynamic site, deliver streaming media, or similar. So our focus around IPv6 has been to help our customers with a smooth transition to IPv6. Because we have so many big websites that use us, being able to have their content available over IPv6 would make a big dent in the amount of IPv6 content available. Also, as our customers are going into a world where we're going to be in a mixed IPv4, IPv6 internet, we want to help them make sure that they go through a smooth transition here, that they have good success from a performance and availability side and don't have issues there. So our focus has been on delivering content to IPv6 and dual-stacked end users from native dual-stacked servers that we've set up around the internet that are close to those end users. However, we're also doing this in an opt-in fashion for our customers because many of our customers would not be terribly happy if IPv6 addresses started showing up in their log lines and request headers right away before they'd had any opportunity to prepare their applications for it. And as a secondary goal, we're trying to help along the IPv6 transition by making more IPv6 content available. So how have we been going about this enabling IPv6 on our platform? First of all, we've been dual stacking the edge servers across our platform. All of the edge server almost all of our edge server software is dual stack capable at this point. However, we've been working with our network providers, and only about a quarter to a third of the I guess 1,700 or 1,900 networks that we're in actually have good enough IPv6 support that we can actually turn on that IPv6 usefully on those servers. So, but at that point, that already means that we have over 25,000 servers that are live in a dual stack configuration with IPv6 connectivity. And for customer properties, we can configure them to terminate both the IPv4 and IPv6 connections in server software out at the edge of our network. But then we can go forwards to the customer origin over IPv4, so that from the customer's perspective, they don't need to make any networking changes immediately to their origin to support IPv6 in order to be able to start serving content out to IPv6 end users. There are some situations where customers will need to make changes to their origin software, such as to handle cookies and log files, IPv6 addresses and cookies, IPv6 addresses and log files, IPv6 addresses and request headers, and so on. And you can kind of think of what we're doing here as a IPv6 to IPv4 reverse proxy, but at a much, much grander scale than one box. If you look at the ways that someone can make IPv6 content available on a dual-stacked site, there are a few different approaches to it. The simplest is just what we refer to as a compliance mode, where you hand out both an A and a quad A record. You're always handing them out. And for some companies, this is exactly what they want. For example, this is what US government agencies want, and what some high-tech companies that want to show that their site is always available over IPv6 want. On the other hand, there are some client populations that may be significantly hurt by trying IPv6 in this scenario. Another approach that's been used is to set up a whitelist or blacklist of name servers, where somehow you, either by metrics or by explicit submission, you collect a set of name servers which is safe to give out quad A responses to. And this has some advantages, and you can help reduce the number of broken end users, but it also is fairly hard to maintain and doesn't necessarily even help in all situations. Another approach you can take is you're going to take that whitelist and blacklist step one step further and to have some sort of performance set up, where while you always return that A record, you look at what sort of heuristics can you employ to determine when to hand out a quad A record. And there are a lot of different factors here that need to be taken into account. You want to make sure that for populations of IPv6 only users, you're not going and making things much worse for them. You want to make sure that you're not sending IPv6 users, or dual-stacked users, far away to an IPv6 server if there's an IPv4 server right next to them. And there may be cases where you need to incorporate whitelist or blacklist information as appropriate. So this can help reduce the risk of enabling IPv6. So Akamai has been focusing on making both the compliance and performance modes available to our customers. Although in kind of the long term, we hope that in a few years down the road, all that we end up is that performance mode just converges to compliance mode, where everything's always getting a quad A all the time. And implementing this, we found, is an interesting challenge, just because you need to have a lot of data available around which client populations are healthy for IPv6, which aren't, where is your IPv6. When you have a name you might want to hand back that is, for your global load balancer, where is the IPv6 name machine, a server that you would want to hand back, and where's the IPv4 server that you'd want to hand back, and how do they compare? So that gets pretty tricky. So that performance mode, again, is where you might always return an A and quad A record for if the IPv6 and IPv4 candidate servers are nearby. But in the situation where the IPv4 server is nearby, but the IPv6 connectivity is likely broken for some end user population, or where the IPv4 server is nearby and the IPv6 server is much further away, you would return only an A record. So what's our current status here? Our focus so far has been on serving HTTP over IPv6 to end users. And we're now in a production beta for our customers and have a number of customers live and are expanding that over the coming months. So more and more sites that are served through us should start becoming available over IPv6 over the coming year. Getting to this point required making changes to over 200 systems across our platform. And the number of changes is in the many hundreds. But now we have IPv6 live in 45 countries, 150 cities in all continents except Antarctica, over 175 networks, which is still only a small fraction of the networks that we're in, and on over 25,000 servers. As far as recent events that have gone on the internet for IPv6 and things that are coming up, back in mid-June, there was World IPv6 Day that was a kind of test drive of IPv6 on the internet, where a lot of sites, including some fairly large sites, handed out Quad A records to see what would happen and just to demonstrate that the internet would not melt. And coming up sometime in mid-2012, although the details are still being worked out, is a next World IPv6 event. And the planning for that's still going on, but it's likely to involve something around getting more content permanently onto IPv6 and having some point where a number of large sites commit to making IPv6 content available, except in cases where it breaks people to large numbers of users or to the whole internet, as well as, but also focusing more on getting more users, eyeballs, and CPE equipment support for IPv6. And in particular, if you're an ISP or CPE provider, then this is probably a good time to talk to ISOC in that planning stage around what you can do to help them for that next World IPv6 event, and I can help get you in touch with the right people for that. Additionally, September 2012 has a US government mandate as a deadline for making all government sites that are publicly facing available over IPv6. And because it is actually a mandate, they're scrambling to do this, and the government is actually pretty far ahead of everyone else in terms of getting IPv6 ready. In fact, we actually have a number of government customers, including the Department of Transportation, that have their websites dual stacked on our platform already. So some observations from World IPv6 Day and what we saw about it. It's kind of hard as a content provider to see what happened on IPv6 Day, given how few users there are there, because the main point was to say, does the internet melt, and did call center volumes dramatically increase from some big sites handing out Quad A records? And the answer to both of those was no. On the other hand, and Akamai served over 50 properties for 20 of our customers on World IPv6 Day, including some major websites you have very likely heard of. And we served over 8 million IPv6 requests to over 280,000 unique IPv6 addresses. On the other hand, that's a very small fraction of the user base for those sites. It was only that means that we saw it being kind of between 0.1 and 0.5% of clients that were preferring IPv6 over IPv4 during World IPv6 Day. And this varied based upon the user base of a site, where they were geographically and demographically. So what sort of lessons have we learned, both in talking to customers, talking with our engineering teams, and talking to network providers as we've been going about implementing this? First of all, one takeaway is that it's best at this point to focus on getting robust dual-stacked IPv6, IPv4 set up, and that in many places, that's kind of the biggest bang for the buck return, because there's going to be a lot of IPv4 users out there for the foreseeable future. That doesn't mean you don't want to start planning and designing for what might things look like in an IPv6 world, where it's IPv6 only. But one thing we've found is when talking to especially management within an organization, the IPv6 problem is such a huge, gigantic, let's redo everything problem. It's kind of like Y2K all over again, but without any hard deadline. That means that it's hard to convince them to start actually really biting into it just because it's too big. So getting them to focus on the things that are most important and the biggest wins as soon as possible can help you get traction in making good IPv6 progress. Another thing is it's likely not worthwhile bothering with using 6-4 Teredo at this point unless you're in a very specialized situation where you actually want to use them for a particular application where you control absolutely everything within a private network. In particular, at this point, because most, at least modern desktop operating systems and clients will strongly disprefer using IPv6 if their only IPv6 address is 64 Teredo, it's very easy to get people confused where they'll set up 64 Teredo, go to a dual stacked site and say, oh, I only went to it over IPv4. What's going on here? So, and we've had that conversation with a few customers in their testing purpose and scenarios. So it's probably better to, if you can, to get people to start using either 6N4 or one of the numerous tunnel brokers that are out there for getting IPv6 connectivity, or even preferably, the best thing to do is if you can get native IPv6 connectivity, and there's becoming more and more of that available. Another thing to watch out for is fun, with quotes around it, with dual stack clients that you might run into, especially since there are many broken and older clients that don't fall back well to IPv4. For example, there are some versions of a major browser that if you have IPv4 dual stacked objects embedded within a IPv4 only page, and there's some connectivity problem on the IPv6 side, it won't even time out. Those embedded images will just show up with errors. Although there was a fix to that browser back in August, but it's probably going to take a while for everyone to pick up that fix. And there's plenty of broken IPv6 to go around. Aaron has a fairly good list on their wiki and long list on their wiki of different types of broken IPv6 scenarios within client software and networking devices. So as I mentioned before, there's this technology called Happy Eyeballs, which can help to some degree. On the other hand, Happy Eyeballs introduces its own set of challenges, especially because now you'll run into situations where clients may actually waffle back and forth between IPv4 and IPv6. And this may cause problems for things that are assuming a stable IP address. For example, if you have a load balancer that's doing IP-based session affinity, that load balancer is going to get fairly confused when clients are sometimes showing up over IPv4 and sometimes showing up over IPv6. Similarly, if you have cookies that embed IPv4 addresses in them, or IP addresses at all in them, then those applications may start getting confused when those auth cookies are coming from a client that is waffling back and forth between IPv4 and IPv6 or using privacy addressing. And there's, because of kind of all the different combinations of IPv4 and IPv6 you can run into, having both of those versions operating in parallel does end up being more than twice the fun. For example, you only see one IP version pair at a time in any client-server connection. Sometimes you need to understand the relationship between them, and this also impacts how you may need to think about your logging and your diagnostics. Another thing we learned is it's good to think about an IP address as an IP address. For example, when you have request headers, log lines, database columns, the naive approach that many developers first jump to is to say, oh, I'll just put in a one header for IPv4 address and one header for IPv6 address. However, when you actually start implementing this, it adds a lot of complexity that's not necessarily needed. So where you can, you're better off thinking of an IP address as an IP address and using the same field for that. And that's what a lot of software out there, such as many of the popular web servers, do when logging IPv4 or IPv6 addresses into log lines. And there are going to be exceptions here, such as when you need to have an explicit 6-to-4 association. And it is useful sometimes when implementing things to have ways to have a single binary data type that you can store either address in. And there is actually, within IPv6, something called an IPv6 mapped address, where you can put an IPv4 address inside of an IPv6 address. Another thing that's critical is you want to test your sites over IPv6 before those sites go live. And as before you hand out that Quad A record, it is absolutely critical, and that's kind of one takeaway from this, to make sure you do that. Because the networking folks and the application folks and the operations folks who are responsible for trying to get that site up sometimes don't talk to each other so well. And the end result of this can be interesting problems. In fact, during World IPv6 Day, there were more sites there's probably more brokenness by sites that handed out Quad A records to broken websites than there was from end users that had problems. In fact, shortly before IPv6 Day, there was a there was a major hardware device manufacturer who went and dual stacked their website, and for a few days, if you went to their website over IPv6, what you saw was a page that just said "Hello World." So from my desktop, and it took them a few days to fix this. From my desktop at work, I tried to go find the contact information to tell them about this, but oops, my desktop was dual stacked and I just got the Hello World page. Don't let this be you. Make sure to do that testing before going live. You also want to make sure, and sometimes it is too late, but it's certainly an area to fix now, is not to embed IPv4 addresses outside of DNS. In particular, this breaks a number of the transitional technologies such as NAT64 and DNS64. And therefore, many of these IPv6 only clients where people are trying to give some access to IPv4 for won't have an ability to do that. So don't put IPv4 addresses in URIs and so on. And as Owen mentioned before, you have to be very careful not to do string comparisons between IPv6 addresses because there are lots of different ways to represent the same IPv6 address. And when you're implementing IPv6, be prepared ahead of time that IPv6 is going to reach very deeply and touch a lot of systems, ranging from client software, your security equipment, networking gear, diagnostics tools, configurations, documentation. Even just think about how many scripts you might have in your home directory that somewhere in that script goes and uses an IP address in some way and therefore might be confused if running host returned a IPv6 address in addition to the IPv4 addresses. And people and training are important and critical too here. Because unless you get people trained, it's very easy to have confusion. And also, not everything that claims to support every IPv6 does. There are a lot of feature gaps and bugs out there, and there's a wide range of problems. And there's also a lot of confusion between how IPv4 and IPv6 relate, and the usability here for tools can be hard. And it's easy to get users confused. You even look at the basic Unix command line tools where like ping and ping6 have two different tools, whereas things like MTR have the -4 and -6 flags to change behaviors. And you kind of expand that out to tools that you're trying to give to less knowledgeable users or even end users, and things get very confusing quickly. And one thing that we found does support IPv6 is bots, or at least some bots. During World IPv6 Day, we actually observed that there was one set of infected hosts that had gone and I guess it was a cluster of WordPress blogs running in some VM hosting provider that had v6 support. And those WordPress blogs had gotten infected and had some bots running on them. And those bots were going and doing some scraping of some sites. And as soon as one of our customers started handing out a Quad A record, those bots happily followed that Quad A record and started scraping things over IPv6. So one thing that it is IPv6 ready is at least some malware. So this may be that your organization isn't fully IPv6 ready, but at least some of the malware is, for better or worse. But the takeaway from that is absolutely critical to make sure that your security software supports IPv6 fully on day one. You don't want to start turning up IPv6 connectivity and say, oh, there's not going to be any attacks over IPv6. We don't need to support IPv6 in any of our insert whatever security system here, because that may just leave you open to an interesting hole, especially with some of the interesting new ways to attack things that can come over IPv6. So in conclusion, IPv6 reaches pretty deeply, but you want to start making progress now, because unless you start making progress now, you're going to find yourself pretty behind. And pretty much everyone, with a few exceptions, are behind at this point. And it's also important to look at where within your organization you can make the biggest bang for the buck. Whether if you're a content provider, there may be some areas. If you're an equipment provider, there may be others. And you also just want to remember that IPv4 is going to be here for a long time. So that's it. If you can find out more about Akamai and IPv6 on our website at akamai.com/IPv6. You can send me email at nygren@akamai.com. And yes, we're hiring.